Hello, my dear students. Now I am here with another video to explain you more about metals and non-metals. In the previous part, we had discussed about how metals react with acids and how metals reacts with metal salt, that is about displacement reaction. We have even understood about reactivity series or metal activity series, where we understood that it's a arrangement of metals in the decreasing order of their reactivity. Highly reactive metals are kept at the top and low reactive metals are kept at the bottom. And I have even given you a mnemonic to remember that metal reactivity series. Keeping that in mind, let us move to the another concept of the chapter, that is how metals reacts with non-metals. Let us understand that under the heading reaction of metals with non-metals. So, in case of metals, they are generally have less than 4 electrons or less than 4 electrons in the outermost shell. When any element is having less than 4 electrons in the outermost shell, it have tendency to lose the electron. Hence, it form cation. This we have studied in your ninth standard, right? So moving ahead, metals generally have ability to lose electron and form positive ion, that is cation. Let us understand it with an example. For example, in case of a metal, let us take potassium. In case of potassium, the symbol is K, right? Its atomic number is 19, right? So if we write electronic configuration that you have learned in your 9th standard, if you try to recall it, that goes to be 2, 8, 8, 1, right? 2, 8, 8, 1. So if you add it, 2 plus 8, 10, 8 plus, 10 plus 8, 18, 18 plus 1, 19. So atomic number. So 2881. In the outermost shell, which is this shell actually, first shell is always K shell, then comes L, M, N. And this outermost shell that is in N shell, there is 1 electron. So this potassium want to lose that 1 electron. Okay, whenever an element loses an electron, it forms positive ion, which is called as cation. So after losing electron, it forms K plus K plus with the electronic configuration 2, 8, 8, which is stable. 8 electron in the outer shell means it is stable electronic configuration. So like this, metals generally form cations. Cations are positively charged ions. Let us move further. Whereas in case of non-metals, they form anion. In case of non-metals, they have tendency to form anion. That means they're ready to accept electron. Let us take in case of chlorine. Okay, Cl. In case of chlorine, the atomic number is 17. As it is 17 electronic configuration, we can write it as 2, 8, 7, right? In the outer shell, it's having 7 electron. This 7 electron, it's very difficult for chlorine to lose that 7. Instead, it can gain 1 electron and make 8 electron in the outermost shell, which can make it to reach stability, right? So this chlorine is ready to gain 1 electron. It is ready to gain 1 electron, and as it gain 1 electron, it will be Cl minus. Okay, Cl minus with the electronic configuration 2, 8, 8. So this is called as anion. Okay, so non-metals form anion, whereas metals form cation. So this is about metals and non-metals property. So if there is an anion and cation, both attract each other. okay, by a strong force of attraction, and that force of attraction is called as ionic bond, and such compounds are called as ionic compounds. So we are going to study a little about these ionic compounds under this session. So both of them react to form ionic compounds. Ionic compounds because they form respective cation and anion. Hence it is ionic compounds. Compounds formed by combination of ions. Metals form cation and non-metals form anion. Let us move further. Coming further, let us go next. If sodium and chlorine were to react, okay, if sodium and chlorine were to react, the electron lost by sodium could be taken up by chlorine. Just now we have seen sodium is having one electron extra, whereas chlorine needs one electron. Okay, it is in need of one electron. So there comes give and take policy. Sodium will give one electron and chlorine will take one electron. Hence the bonding gets formed, that is ionic bond. After gaining an electron, the chlorine atoms get a unit negative charge because its nucleus has 17 proton and 18 electrons in its KLM shells. About this discussion we have done in 9th standard. Okay, so whenever an element gain electron, its number of electron increases, which was previously equal to number of protons. Protons are positively charged, electrons are negatively charged. When electrons are more than proton, then the charge on that particular atom is no more called as atom, it's called as ion, will be negative. If protons are more than the electrons, then the charge would be positive. Okay. This gives us chloride ion, Cl minus ion. So both of these elements can have a give and take relation between them to form ionic compounds. So this is how the reaction takes place. Observe carefully, children. Okay, so here Na is there, 281. Okay, it's electronic configuration which I had written shortly. Sorry, I had written for potassium, and this is for sodium with the atomic number 11. So 11 is its atomic number, hence 11 is its atomic number. Its electronic configuration is 281. Okay, when it loses one electron, this is one electron that's been lost by sodium. It forms Na plus with 28 sodium cation, and Cl minus, which is 287. Okay, because its atomic number is 17. As its atomic number is 17, it's 287, 7 in the outer shell. So this will gain one electron. This is gain, okay, whereas here it is loss. Here it is loss, whereas here it is gain. Cl minus 288, chloride ion. An ion is formed. Here sodium cation is formed. So this one electron from the sodium is given to chlorine. Chlorine electrons are shown with cross mark. Sodium electron is shown with a dot. So sodium become Na plus, Cl become Cl minus. Can you see here? Cl minus. All together it's called as sodium chloride. And this particular method is called as electron transfer method to form ionic compounds. Sodium and chloride ions being oppositely charged attract each other and held by strong electrostatic force of attraction to exist as sodium chloride. What is this sodium chloride? It's nothing but common salt which we use in our kitchens daily. Okay, sodium chloride is a salt, common salt. Let us similarly see how ionic bond gets formed between magnesium and chloride. Formation of magnesium chloride. Before we see the image, let us discuss, okay, from your memory, magnesium. What is its symbol? Do you remember? Magnesium symbol is Mg. Okay, and its atomic number, try to recall it from your mind. It is 12. Electronic configuration shall we write? 2, 8, 2. Sorry, 2. Okay, so it is ready to lose 2 electrons. If it loses 2 electrons, it forms Mg2 plus. Okay, Mg2 plus with the electronic configuration 2, 8, 8. That's it, 2, 8. Similarly, chlorine, if we'll see. Okay, chlorine, if we'll see, Cl with the atomic number 17, its electronic configuration will be 2, 8, 7. Right, 2, 8, 7. Yeah. So now chlorine will gain an electron. It will become Cl minus with 2, 8, 8. Okay. So this magnesium is giving how many electrons? 2 electrons are given by magnesium. Okay. 2 electrons. Last 2 electrons are given by magnesium to chlorine. Okay. But chlorine want how many electrons? Only one. Chlorine want only one. So what magnesium does is one electron will be given to one chlorine atom, another to another chlorine atom. So two chlorine atoms combine with one magnesium atom to form magnesium chloride. Let us see it with the image, with the help of image. So Mg282, it will form Mg2 plus 2 electrons are lost. These 2 electrons will be taken up by chlorine. You can see here 2 chlorine atoms are there. One chlorine want 1 electron to become 288 Cl minus. Here 2 chlorines are there. Each chlorine is receiving 1 electron from Mg. So it is forming Mg2 plus Cl2 minus. Hence the formula of magnesium chloride is MgCl2. It is MgCl2. Okay, 2 because 2 chlorine atoms are there. Okay, 2 chlorine atoms are there in one molecule of MgCl2. And magnesium atom in one molecule of MgCl2 is 1. So this is about formation of magnesium chloride. These electron transfer methods are very important, children. In examination, they'll ask electron transfer method for formation of ionic compounds like NeCl they can ask, or MgCl2 they can ask, or either they can ask sodium oxide. Okay, sodium oxide also they can ask. Na2O is its formula. Na2O. Okay, or they can even ask calcium oxide. Calcium oxide, CaO. So you should learn how the electron transfer method happens for these two, sodium oxide and calcium oxide. They can ask any of this for 2 or 3 marks in your main examination. Properties of ionic compounds. Let us see what are the properties of ionic compounds. It's also very important. Application level questions, reasoning type of question, 1 mark questions can come from these properties of ionic compounds. Physical nature. They are generally solids but brittle. What do you mean by this term brittle? Brittle means which break into pieces. Brittle meaning is it break into pieces. Break into pieces. So they are generally solids, but they break into pieces. For example, you have seen salt. Salt is solid, which we use in our kitchen. Okay, cooking salt or table salt. It's generally solid, but it is brittle. If we'll hit it, it will break into pieces, right? So physical nature, generally they are solids, but they are brittle. Let us move further. Ionic compounds have high melting and boiling point. This is because of considerable amount of energy is required to break strong interionic attraction. This is also important. Why ionic compounds have high melting and boiling point? That's because interionic attraction is very strong. To break that interionic attraction, we need to supply very high energy. Hence, its melting point or boiling point is high. Solubility. They are soluble in water but insoluble in solvents such as kerosene, petrol, etc. They are soluble in water. Do you know why it's soluble in water? That's because water is also having ionic property. Okay, why water is also called as universal solvent. It can also be called as ionic solvent. Okay, so you need to remember in case of solubility, like dissolves like dissolves like. ಅಂದ್ರೆ ಯಾವುದು ಅಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್ ಇರುತ್ತೋ ಅದು ಅಯಾನಿಕ್ ಸಾಲ್ವೆಂಟ್ಸ್ ಅಲ್ಲಿ ಆರಾಮಾಗಿ ಕರಗತ್ತೆ. ಓಕೆನಾ? ಯಾವುದು ಕೋವಾಲೆಂಟ್ ಕಾಂಪೌಂಡ್ಸ್ ಇರುತ್ತೋ ಅಂದ್ರೆ ನಾನ್ ಅಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್ ಇರುತ್ತೋ ಅದು ಅಯಾನಿಕ್ ಸಾಲ್ವೆಂಟ್ಸ್ ಅಲ್ಲಿ ಕರಗಲ್ಲ, ಬಟ್ ದ ಡಿಸಾಲ್ವ್ಸ್ ಇನ್ ಕೋವಾಲೆಂಟ್ ಸಾಲ್ವೆಂಟ್ಸ್. So kerosene, petrols are not ionic solvents, they are covalent solvents, whereas water is ionic solvent. It's ionic solvent. So you should remember this, like dissolves like. Like dissolves like. ಯಾವುದು ಅಯಾನಿಕ್ ಸಾಲ್ವೆಂಟ್ ಅದರಲ್ಲಿ ಅಯಾನಿಕ್ ಸಬ್ಸ್ಟೆನ್ಸಸ್ ಅಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್ ಕರಗತ್ತೆ. ಯಾವುದು ನಾನ್ ಅಯಾನಿಕ್ ಸಾಲ್ವೆಂಟ್ಸ್ ಅದರಲ್ಲಿ ಅಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ಸ್ ಕರಗಲ್ಲ. Then conduction of electricity. Idra melu kuda they can ask 1 mark question. Okay, 1 mark kelbahudu. 1 mark question anna kelbodu. Then conduction of electricity. Produce ions in water that helps in conduction of current. Ivo ionic compounds agirodrinda they produce ions which make them conduct current. So these are very important properties of ionic compounds. So let us go for another slide, maybe questionnaire. Okay, here comes from your understanding, you should try to answer it. A question that's based on our understanding till now. A metal X combines with metal Y by transfer of electrons to form compound Z. Okay, here is a hint for you. X combine with Y. X plus Y to produce compound Z. Okay, state the type of bond in compound Z. They have given here metal X. X is metal. They have mentioned X is metal and Y is non-metal. So they are asking type of bond in compound Z. It's very much clear from our previous understanding that the type of bond in compound Z is ionic bond. What can you say about melting and boiling point of compound Z? Is it high or low? What do you say about it? Ionic compounds generally have strong ionic force of attraction, hence their melting and boiling point is also high. Will this compound dissolve in kerosene or petrol? You should remember, like dissolves like. Does it dissolve in kerosene or petrol? No, but it dissolves in water. Will this compound be a good conductor of electricity? Yes, it is a good conductor of electricity because it produces ions that carry current. Hence, it's a good conductor of electricity. So I have answered the questions for you. Try to search for this kind of questions that help you to increase your understanding or apply the concepts that you have studied. So till now we have studied about ionic compounds and its properties. Next concept is about metallurgy. Yeah, one more question is that explain the formation of ionic compound CaO. As said, calcium oxide is important. With electron dot structure, atomic numbers of calcium and oxygen are 20 and 8 respectively. Calcium is 20, oxygen is 8. Based on this information, you should write the formation of calcium oxide with electron transfer method. Okay, that's all for today. Let's catch up with another video shortly about continued discussion of the chapter metals and non-metals. If you find any concept difficult, if you want me to explain, please feel free to comment. I'll do the needful. Thank you. Hope you are liking the lessons. If you definitely like the lessons, do share with your friends and subscribe, like, and comment. Thank you. Thank you for your patience listening.